Hello, hello, hello. Welcome back. Today I'm going to be talking about test-driven development. Test-driven development is a completely different way of approaching a problem that most of us naturally don't follow, and we're not even taught in school. My brother, when he was in grad school, he was asking me for help on something. He's an electrical guy, and he was learning C programming for whatever. And I had told him, I was like, no, I'll get you a CPP unit. We'll get you a unit testing framework and you get all this stuff. And he's like, I just need to get this project done tonight. I'm like, yeah, we'll get it done tonight. And he just threw all my suggestions away because it was not how he was taught to think about solving problems. So, but he's moved on and then you learn it later. But test-driven development forces us to create more complete and reliable solutions. And today I'll be talking about what makes a difference and how it can help you in your development process. All right, a standard way of solving a problem is just to up and write the business logic to solve the problem. While this might give you a quick win, it definitely makes more work for you in the long run, or it can. On the other hand, test-driven development encourages you to only write the code you need. It gives you more modular design by default. It is easier to maintain and refactor. It demonstrates and documents how a piece of code is expected to be used, letting you clearly express to all of your teammates what your code should be doing, and also future you, because future you is going to look at you, current you, and be like, man, I'm dumb. I was so dumb. What was past me thinking? So it documents that enough to clearly express to you what you were thinking about doing and how it should be working. And then it changes the way that you debug a problem, and it changes the way that you think about solving a problem. So let's see it in action. All right, here we've got some really simple Python code. So we're gonna take in two arguments, a left-hand side and a right-hand side, and we're gonna make an operation to do it. And so this is what we've done. We've written up some code. I said, okay, I want to read some stuff from the command line. So I do some argument parsing. I'm going to do one number and then another number, and then we're going to print out the result of that number. Okay, and that's it. So I'm going to do some computation. So that's what we've done. We've solved the business logic. We are done. We are fixed our problem. So I can give it to my customer, and I can say, oh, yeah, you just run this. We say Python 3, and then we say my Python code.py, and then there it goes. Oh, you got to follow the, look, see, it's error checking and everything. It's got all this. So we're going to say this, and we're going to say 3, 4, 7. Perfect. And then we're going to say 5, 6, 11. Amazing. I'm an amazing programmer. I did the job. I get to clock out, go home for the day, and hope I never see this code again. Whereas in test-driven development, I'm going to flip it on its head. The first thing we're going to do is we're going to think about how is this supposed to be used? Or how is our operation supposed to be used? What are the inputs to it? What am I thinking what it's going to do? And what we're going to do is we're going to write the test first. We're not going to write the business logic first. We're going to write the test first. So we think, all right, so I'm going to define a test. And I'm not going to print hello world. Thank you, Copilot. I'm not going to do that. First thing I'm going to do is I'm going to say assert, and then I'm going to call a function called operation. I'm going to pass, yeah, there we go. I said 1, 2 equals 3, okay? And then, I'm going to go over here to my command window, and I'm going to say python 3-m pytest, and I'm going to say my python code.py. Operation is not defined. Okay, well, all right, I'll do this, and I'll say def operation, yeah, AB. Oh, Copilot's so thoughtful. There we go. AB, there we go. And I do this, and I passed. I did such a good job. I don't have to do anything else. I can go home. Wait, let's finish this. Keep working. Let's keep working. Okay, so we're just doing an addition here. I can do 1, 2. I can do 1, 4. That should equal 5. I can say 1, 0. That should equal 4. And I'm going to run that test. What? 1, 0 is 4? Oh, no, it should not equal 4. That should equal 1. What was I thinking? So now we've got some rigor in there. So we know exactly how our function is going to be behaving. Now, if I want to package this up into a library, I can package this up into a library. They can have the operation function without having to call main. So if our end user is wanting to include this in a library instead of just printing it out to the screen and parsing the print, we already can do that. You can just leave it as it is. Or we can also recreate the scenario that we had already created before with our arg parse. Okay, I'm going to call operation there. So now I can run my test, and I can still Python 3 dash, oh no, not even dash m, my Python code.py, and there we go. We've got 3, 4, 7, 5, 6 is 11. But each one of these, so instead of, and then every time we want to go build this, so when this gets pushed up into a CI/CD or some sort of automated testing framework, we can run those tests. We can run that test, and then you'll notice when I run my test, I can echo $, and it's 0. But if I come back over here and I change this to fail, and I know this is going to fail now, I can run it again. Not only does it print out some red stuff on my screen that says failed in big letters, I can echo that and it returns 1 instead because the testing framework automatically accepts that. So we can push that up into our automated testing framework and then use that to validate that our code continues to work the way we expect it to work. All right, and that's all there is to it. Test-driven development really changes the way you think about addressing your coding challenges. It forces you to write more maintainable, more modular, and better documented code that will increase your productivity, make it easier to work with the rest of your team, and stop you from tripping over your own feet. All right, next up, we'll be applying this concept to a more embedded systems environment. If you're on the website, go up here, click up here, and download, and try out our community edition of our software. If you're on YouTube, go down this way, scroll down a bit, and like and comment and subscribe to see more videos for how to make how to make more better software faster. See you next time.